will be demonstrating the code for our final project and explaining each relevant use case. So as we explain our code, I'm going to run the application and have it running in the background. So if we hit new session, the countdown timer starts and we see that the session started and we're calculating baseline frequencies for each electrode. Alright, so we'll just have this running in the back, and meanwhile we'll explain the neuroset connection first.
So in the start session function, it emits the start model sesh signal, which is connected to the neuroset controller. If you could go to neurosetcontroller.cpp, it is connected to the start sesh function. So that creates a new thread for session thread. It creates a new session for current session. It connects the start function of the session to the session thread, and then it moves current session to that thread, and then it starts that session thread. So as you can see, the connect to thread function connects the start of the thread to the start function in session. So in the start function in session, you can see it starts the session and then it iterates. So in the first for loop, it iterates through all the electrodes and calculates the before treatment calculation, and it gets that before baseline frequency and it adds it to the total, and then it averages it out and then prints that out afterwards. And then it iterates through all the electrodes again in another for loop. It starts the treatment on all the electrodes. And then in the third for loop, it iterates through all the electrodes and starts the baseline calculation for after the treatment and adds that to the total for after, and then it averages those out and prints those out. So in electrode, so if you could go to the electrode class, start treatment, it iterates or it goes for 4 rounds. It does the get dominant average according to the average equation in the testing rubric.
So yeah, so for battery depletion, as we can see, the session has completed successfully, and after each 2 to 3 sessions, so after each session, the battery depletes a certain amount of percentage based on the number of sessions ran, and once it reaches a total of 3 sessions, it would deplete to the bottom. So this is pretty much divided by 3, as stated in the spec, for it to deplete after 2 to 3 sessions. The next thing that was also implemented was the power on and off button. So once the power off is clicked, the system provides you with a message stating it's powered down and it asks you to power it back up for it to use. And so when this is hit, all the buttons are disabled. And the same thing happens when the battery depletes all the way down to 0%. All the buttons get disabled.
So basically, the test2i segment, all it's really doing is it goes through. So if you can pull the main window up real quick, if you look at the drop-down menu real quick here, so you see how there's a drop-down list with the text on it. It just parses that to find the number of the electrode you're currently trying to select, and then it just goes to it references that electrode in the electrode list that is in the instance of the neural controller that's in main window, and all it does is get the amplitude and frequency. It puts it into a sinusoidal wave function, and then that's just put on main window, and that you can see is different for all the electrodes.
Okay, so the main thing that we want to be able to cover is that as the sessions are running, they're constantly storing the signal information and the baseline frequency until it is either paused or ended. Once a current session is ended, we store that session's information in our list of past sessions, which you can get from here, and display all the same information it had while running, including the ended baseline frequency. This is due to the centralized design of our code, where Neuroset Controller has everything connected to it and stores all the session history. Every time we make a new session, we append that session to our list of sessions. So we simply use the getter of session history from our Neuroset controller function, and then we're able to see and display everything that we need to.
And so as you can see, our app has multiple lights which signify different parts. What we care about is the red one, as it represents disconnected/low battery, And based on our use case, our app would continually monitor the connection between the electrodes and the device. And then the device would warn the user if disconnection is detected, which is shown through the red light at the top of our app. And the user can reestablish the connection as the session is automatically updated. And then the device would store any session data and end the session if the connection is not made again. Also, it should be noted that our demo of the application's various features, as referenced by the use cases, we have consequently shown the different requirements from the requirements traceability matrix.
Great, and we'll also
That's it.
cover one last thing with the PCUI. It also kind of discovers the fact that each session log created is also coincidentally is displayed on the PC, which can be used for further analysis and display of each session log. And yeah, that's the demonstration for our group project. Thank you very much for watching. Take care. Have a good one.